Okay, so in this tutorial we are going to be slicing ranges of cells from data frames that we load from Excel into Python/Pandas. And we're also going to be showing you the different ways of displaying those extracted cells. So here's the three ways. We have with, row labels, and column headers. We have just the data, and then we have column headers with data only, so no row labels. And after ranges, I'm going to show you how to do basically the same thing, except for just doing entire rows or entire columns. So as we always do when we're working with data frames, we have to load it into a variable first. So I'm using the variable df for my data frames, and I'm using the quickest way to load Excel data into a data frame, which is equals py tab and selecting all the data with the headers and pressing Control Enter. So that is what we get when I do that, and I want to use the one where I defined it in a variable here. So I'm going to delete what I just did. Okay, and then so for the first example, we're going to extract rows 5 through 10 from columns 3 through 6. So this highlighted select set of data. And the way we're going to do that is with the, it's called an indexer in Python. The Pandas library has one called location that's pretty straightforward that we're going to be using. The way you use it is you state the data frame variable, and then you type in .loc, and that stands for location. And then, unlike functions, indexers use square brackets to enclose their arguments in. So we do a square bracket, and then the first argument is the range of rows, and the second argument is the range of columns. And when we're identifying ranges of rows, we don't need quotes, and the through word is just a colon. So this signifies 5 through 10 and column 3 through column 6. So first parameter is rows, second parameter is columns. Use the colon as the word through, and column names need to be in quotes because they are strings. So that's going to give us a data frame that looks like this. We have rows 5 through 10 and columns 3 through 6. Now, if we want to display that back in Excel, there's basically 3 different options you can do. The first one is the simplest, and that is just to simply restate the variable that we defined when we extracted the data. So we just state that in an equals py cell and press Control Enter, and that will return everything. So all the row labels and all the column headers along with all the data. And then the second way we can show the values is just as the values only, no column headers or row labels. And the way we do that is we just type result or whatever, this is just the name of a variable, and then we set that equal to the extraction data frame dot values dot to list, and that's going to convert all the values from the data frame into a list. And then the next option, which might be the most useful out of all 3, I would say, is to extract just the column headers and the data, which unfortunately is the most long form, but it's not too bad. First, we have to extract the column headers, and we do that by referencing the data frame and then typing .columns, and that's going to give us a set of all the column names, and then we type in .tolist, and that method is going to convert all the column names into a list. And then we have this part of the code, which is this same data frame, except instead of .columns, it's .values. That's going to give us all the values in the data frame. And then we use the same method, .tolist, and then in between we have a plus sign. So basically we're going to be adding to the list of column names the values. So So hopefully that makes sense. If it doesn't, just leave me a note in the comments and I can address it in more detail. And all of these ways of displaying data frames are applicable to all the examples I'm going to be going through. So sometimes you might want something like this, so they're not like connected in any way. And the way you do that is you state your variable name and then we reference that original data frame that we did in this cell here. Type in block just like the last example, except this time when the rows or columns are not right next to each other, you have to put them in a list. So we have, and the way you make a list in Python is you just use square brackets around values separated by commas. So if we want rows 3, 6, and 9, we just put that in square brackets, and that's going to be our rows argument. Then we have a comma, and basically the same logic goes for columns, except again, we use quotes around the column names because they're strings. Don't have to use quotes around rows because they're row numbers because they're numbers. So if we do that, then we get something that looks like this. So we have row 3, 6, and 9, and then column 2, 6, and 8. And then on this sheet, I basically have the same thing, just a random array of numbers here. I loaded them into a data frame just like I did in the last examples, except on this sheet, I am showing you how to quickly slice entire rows or entire columns. And it's like a shorthand method, so you don't have to know exactly how many rows there are or exactly how many columns there are, because a lot of times you're going to be working with like hundreds of thousands of rows. So this little shorthand trick will make your life easier. So just like I did in the last example, I, name the variable something useful and informative, and then reference the data frame .location or .loc, which stands for location. And then we have the square bracket to start the arguments. And then we have rows 2 through 6. And then when we put the main idea on this sheet is that when you want all columns or all rows, you just put in just a colon for the argument. So this will return rows 2 through 6 with all columns. And that is rows 2 through 6. And then we have at the top column 1, 2, 3, 4, 5, 6, 7, and 8. And that's all the columns. And then this example is pretty much the same thing, except just exemplifying how you can use just the colon to symbolize all rows as well. So this will return all rows for columns 3 through 8. All rows, well, first 5 rows, last 5 rows, and these little dashes mean all the rows in between, or these little ellipses mean all the rows in between the first 5 and the last 5, and then we have just the columns we specified, rows 3 or columns 3 through 8. And then down here is just showing you it's the same exact logic as this sheet. That's it for this video. Let me know if you have any comments or questions or ideas for future content for me to cover. Thank you so much for watching, and please subscribe.